Hi, hey guys, study with me, okay? So for studying with this test, it seems like there's a ton of material, and you're right, there is. But all you really need to identify is the heavy hitters, the big overarching concepts that will be tested on the test, or you have to review the stuff you don't know. As we scan through the notes, we're going to do our preliminary scan. Then we're going to go back and use the review materials that I prepared for you guys. And hopefully I'll be able to find you all the heavy hitters, and then you can have a jumping off point to figure out the stuff that you don't know. So right now I'm going to skip this stuff that's in the beginning here because these are all kind of review pages, and we will go back to that at the end once we've done our preliminary scan, okay? So heavy hitters. Let's look at the headers for each topic, right? So types of data and types of sampling. So what are you going to need to know in this little spot right here? Okay, so we know we can have qualitative or quantitative data, right? And then we know that we can have discrete or continuous data. So you got to know data types, methods of sampling. All right, so you're going to need to know continuous versus discrete. And then you're going to need to know different types of data. Sure, that's not really going to be too important on this test. You do need to know the difference between qualitative and quantitative data. You need to know the difference between a sample and a population. And then you need to know how to find an outlier. So in order to find an outlier, we'll talk more about that when we get to box plots. So we'll just keep scrolling. All right, different types of sampling. Hello, let's go back. All right, so you've got quota, systematic, stratified, simple random. These are all the good ones, and then the bad one is going to be convenience or voluntary response bias. Okay, so those are going to be data types, methods of sampling. All right, and then we're scrolling through. Do you remember doing these problems? Like, do you think you could be able to answer them on your own now? Yeah. All right. So then now we get to 3.6, presenting and describing data. So we could have histograms. These are used for continuous data. This is when we group data into bins or groups, right? And you can generate a frequency column, and then you have your X column in the left. Would you be able to reproduce a histogram if you had to? So we're now in 3.6, presenting data. So you have your X list. You have your frequency list. These are in groups. All right. And if you had to, if you had to go ahead and approximate the standard deviation or mean of grouped data, you take the midpoint. You take the midpoint of each group, and then you multiply it by the number of items or frequency in that group, and then you would run 1-bar stats. Okay. So you keep going, scroll through these problems, look at these problems. Do you remember doing these? Do you know how to do them? This is just the way that your data would look. Make sure that you know how to calculate 1-bar stats. Make sure that you know how to calculate 1-bar stats on just an X list, where you type in just a bunch of data points for an X list and then you do 1-bar stats. But also make sure you know how to calculate 1-bar stats when you have a frequency column like outlined above. Okay. Okay, 5-number summary. That's going to give us the mean, the median, the min, the max, the Q1, and the Q3. Oops. Okay. So now for, remember also with the standard deviation, you always want to take the population standard deviation from your calculator. You don't want to take the S sub X. That one's bad. Okay. So describing data, measures of center. Okay, so when we talk about measures of center, we're talking about the mode, the number that comes up the most, the median, the number in the middle, and the mean, the average. Okay. This whole exploration here goes into the details of how we find the standard deviation or the mean in grouped data. Again, we already talked about that right here. You would have your X list and then you would have your frequency column. Measures of dispersion, that's going to be how spread out your data is. And the things that we use for dispersion are going to be the IQR, box plots. Box plots are generated right from the 5-number summary. And the standard deviation. Okay, so remember that the standard deviation is the square root of the variance. So the variance is the standard deviation squared. Then if we wanted to find the standard deviation from there, we would take the square root of the variance. Okay. Oops, why does it keep going so fast? I don't like that. Okay, so make sure that you would be able to contextualize the standard deviation. What happens when we remove a data point and how does that affect the mean? Can you figure out where the median falls in a list of data points, especially where this is like an X column and a frequency column? And then let's talk about constant changes on data sets. Okay, so we're still in our 3.6 day. So maybe you want to write this down. Constant changes on data sets. So in constant changes on data sets, let's see. Let's look at our notes here, okay? It says you might be asked what happens to the mean, standard deviation, or variance if a basic operation was carried out on every data point, okay? So any operation changes the mean in the same way, but a plus or minus just shifts the data. So plus or minus does not affect the standard deviation or variance. Okay, but a plus or minus does affect the mean. You would just add or subtract that same amount. So multiplication or division, it does affect the mean, and then it also affects the standard deviation as well. So I'm going to put that down. This affects all of them. Affects all of them. Okay, so let's keep scrolling through and see if we're going to miss anything in here, okay? All right, so this was talking about constant changes on data sets, yeah. All right. Okay, and remember, if we wanted to find the standard deviation or the mean of anything from a list, we would just type it into one of our stats. Okay, and you can always check and add or subtract the same number to every data point, multiply or divide the same number by every data point in your little list in your calculator if you wanted to double check on the day of the test because you forgot. Okay, and it talks about the median and standard deviation. Okay, great. Let's see what else. Now we've got quartiles and box plots. Okay, so in a box plot, we have our 5-number summary. And that's going to look like, actually, I do want to make a quick little distinction here, right? So if I have, let's see, a standard deviation of 3, right? And I multiply every data point in the data set by 3. My new standard deviation is going to be 3 times the old standard deviation. So that would be 3 times 3. So that would be 9, right? And then if I have an old standard deviation of 3, and then it wants me to find the new variance after I've multiplied every data point by 3. So I would be like, okay, well, first I need to multiply every data point by 3 and get the new standard deviation. And then that standard deviation squared is going to give me the new variance. Okay, just a little side note there. Okay, so because variance is standard deviation squared, so I just wanted to like hit home on that point. Okay, so we have our 5-number summary, so that's going to be our min, Q1, median, Q3, max, and those are located on the box plot in the following spots. That's my washing machine. Hope it's not too loud. Okay, so you've got your min, Q1, median, Q3, and your max. This is where they're located. Just remember that this is the middle 50% of the data, aka the IQR, and the IQR can be found by doing Q3 minus Q1, or if you're talking about percentiles or in a normal distribution curve or something like that, it's going to be the middle 50% of the data, or if you're talking probabilities, there we go. So like something like this. This is Q1, this is Q3. This would be, oops, it erased all my stuff, but this would be the middle 50% of the data. Okay. All right, so that is my box plots, IQR, all that stuff. Oh, the test to find an outlier. So you would do Q1 minus 1.5 times the IQR, and that's for your lower bound. And then Q3 plus 1.5 times the IQR, and that's for your upper bound. All right. Okay, this is for making box plots on your TI Nspire. Just read through that. Do you know how to do that? We got some box plots, some outlier tests. Read through these problems. Do you know how to do those? All right. And then comparing box plots, just remember that you always have to put them on the same scale. Otherwise, you have no idea what's going on with one box plot compared to the other. Read through these problems. You know how to do them. Okay, cumulative frequency histograms. Okay, so cumulative frequency histograms, right? We are now no longer just concerned with the frequency in each category. We are now going one step further to find the cumulative frequency as we move down the entire grouped list of data. We are then going to graph the upper bound of each data class, which is on the x-axis, versus the cumulative frequency, which is on the y-axis. Okay, make sure you memorize these formulas to find where the key data points are located. So cumulative frequency, what was this, 3.7? Yeah, so remember, study like you're making a test, right? Okay, this was another big category, 3.7. This is cumulative frequency. Okay, so you have cumulative frequency, and then you have upper bound of each class, and it's going to have this kind of characteristic S shape, okay? And the way that you find Q1 is going to be N over 4. The way that you find the median is going to be N over 2, sorry. N over 2, and then the way that you find Q3, my dog will not stop walking around, is going to be 3N over 4. And that'll give you like that data point on the y-axis, and then you're gonna have to go down and see what it reads on the x-axis for like answering a question. Okay, scroll through these problems. Do you remember constructing one? Do you remember reading one to answer questions about it? Okay, just remember that if they give you the total number of participants or things that were canvassed, make sure that your cumulative frequencies end up adding up to that number. And then this was a great homework if you want to read through these problems and just see like, okay, which ones did I get? Which ones don't I still get? This is a summary of like all the descriptive statistics that we did in the earlier part of the unit. Okay, and then once you scroll through these problems and kind of identify what you're good at and what you still need help with, then you can study those pieces accordingly and go back to your notes and double check. Now we are going to correlation coefficients. Okay, so correlation coefficients is going to be our R, and that's our Pearson correlation coefficient. And that measures the strength of the linear relationship between two variables. And when you are explaining this, or when you are explaining or describing the Pearson correlation coefficient, how it pertains to the data, you must mention the strength So is it, you know, close to 0 or close to 1? And you must mention whether it's positive or negative, then that's indicating the general trend of the data. Would the trend line be with a positive slope or would it have a negative slope? Okay, positive or negative, and that's pertaining to the slope of the trend line. Okay. All right, that was our lab. Yay, so fun. Okay, now let's look at this. These are great visuals, okay? Study these, right? As I look and see an R value that's close to 1 is going to be a perfect correlation between the two, and then an R value that's close to 0 is going to have no correlation between the two, and then as you get further out from 0, you become weak, strong, or perfect, okay? Remember our class research question, the calculation of R squared, the coefficient of determination, that is only for your IA. You will not be tested on capital R squared. You will, however, need to know R, the lowercase Pearson correlation coefficient, as it pertains to linear equations. All right. Linear regression, rather. Okay, so you got to know the difference between linear regression types. So we have y on x, that's the traditional one, y equals mx plus b. And we have x on y, that is where you have x equals, and then mx plus b. So, or my plus b. So it's the same process as a linear regression, but you switch your inputs for the x and y list when you do x on y, okay? And if you ever need help remembering which one goes with which, you can do y on x. You can draw your little arrow and write depends on. So y depends on x, so that one's going to look like this. And then if you have x on y, x depends on y, you have x equals my plus b. My feels so weird. Just know that these both pass through the mean. These both pass through the mean point. X bar, Y bar. And the way that you can find that point, if it's not given, is you can do 2 var stats if you have an even number of X's and Y's, or you can just calculate individually with 1 var stats if you have maybe more X's than Y's. All right, so you can scroll through these problems, see if you caught everything. We didn't do Anscombe's quartet in class. It was just practice graphing regression equations and stuff. So let's look at the linear regression questions that you were asked about on the homework. Can you type it in your calculator and get the proper regression? Can you draw a trend line? Remember that a trend line should have an endpoint over here and then carry on with an arrow on the end, okay? And you want to try to hit it through as many data points as possible, and it's always going to pass through X bar, Y bar. Okay. Scroll through these, see if you would need help with anything else. Oh, remember interpolation versus extrapolation. So interpolation is when you make a prediction based off of a data point that was not specifically measured. That's going to hit right on the data point. That was not specifically measured like during the experiment, but it is well within the domain of, like, say, the given things that you were exploring. That would be interpolation. He is okay. Not given data point in domain. And then extrapolation, extra, outside of, no good. That is when you are, you know, say testing a value that's like 20. Your model doesn't go all the way up to there. You only asked up to 10. So extrapolation is no good. Okay. Still looking, looks good. Okay, binomial distribution, 3.11, binomial distribution. So a discrete probability distribution, that's going to be the one that looks like this. We know that these all add up to 1. In the bottom row, you have discrete outcomes outlined on top. A binomial distribution is when you have a fixed number of trials, probability of success, and an exact number of desired successes. In your calculator, this translates to the n, the p, and the x, and you would double check on your calculator. Do you know how to get to the binomial PDF function? So you would pull up your calculator and you'd be like, okay, menu 55A. All right, so menu 55A, and then you see NPX are the inputs. Do you know what those mean? Okay. This is when you have an exact number of desired successes. So your keyword would be exactly 5, exactly 3. Okay. Let's scroll through and see. These were reviews of probability distribution problems. We talk about the difference between binomial distribution and the formula. Remember that you are given the formula booklet under binomial distribution, so if you ever need it, you won't on this test. I'm not saying that binomial distribution isn't going to be on this test. I'm just saying you're not going to use the formula on this test, but at least you know where to find it and how to translate it into a binomial distribution if you needed to. Okay, so now we need to know the difference between binomial PDF and binomial CDF. So this is the first thing you had to know. This is the second thing you have to know. Binomial CDF. So let's look at our inputs for binomial CDF. Do you know how to get to it on your calculator? Menu 5, and then B. And then look, you need your fixed number of trials, you need your probability of success, but now you need a lower bound and an upper bound. So you can remember that binomial CDF is used for a range of desired outcomes. So you have your N, you have your P, but then you also have your lower bound and your upper bound. Okay, so that means like your binomial CDF function is used for calculating at most 3 successes or something like that, right? So you can have 0, 1, 2, and 3, but you can't have any more than that, okay? So that's what we mean by a lower bound and an upper bound. You have to read the question and see where they want you to start taking your desired number of successes and when they want you to stop. Okay, remember that if you're ever comparing sums on 2 die, you're comparing one outcome to the other, you should always illustrate your sample space with a little chart. Okay, look at these problems. Do you remember doing these problems? Do you remember how to do these types of problems where you have a desired outcome on a desired number of tosses, right? You're going to have like a mini binomial PDF, and then you have to multiply by the final outcome at the end, something like that. Sorry. Can this calculator like get out of here? This is in the way. Okay, there we go. Now remember, if they ever tell you to find the expected value and it's not a probability distribution, it's a binomial distribution, E of x is equal to n times p. All right, look at these homework problems. Do you remember these homework problems? If you get stuck on any of these, I made you videos for them. They're in Google Classroom. You can go back and look at them. Do you understand how to set all these up? Cool, cool, cool. Okay, so now we're at z-scores. Yay, we're almost done. So I have 3.12. This is z-scores and the norm distribution. So the most important thing in the normal distribution, right, you got to know what percentage of the data is located within how many standard deviations of the mean. So this is -1 standard deviation, negative meaning being negative because it's below the mean. This is 1 standard deviation above the mean. What percentage of the data is located between 1 standard deviation? And then you can look right on your notes and be like, oh yeah, I can make myself like a little chart. Okay, so this is going to be 68%. And then within 2 standard deviations, this is below, this is above. There's going to be 95%. And then within 3, there's going to be 99.7. All right. And if you'll notice in the standard normal distribution curve where you have a mean of 0 and a standard deviation of 1, these correspond to the z-scores. So this would be a z-score of 1, this would be a z-score of 2, this would be a z-score of 3. And do you see how we know what probability is located between a certain number of standard deviations in the standard normal distribution? Yes, we do. And that's what's happening when we standardize or convert something to a z-score. So standard normal distribution, he has a standard deviation of 1 and a mean of 0. Excuse me. All right, so read through our notes from that day, right? We use normal CDF when we have an unknown area or probability. We use inverse norm when we have a known area or probability. Okay? Know how to get to the norm CDF, know how to get to inverse norm on your calculator. Test that out right now. Do you remember how to get there? If not, that's okay. You can go to this page and double check. So when do we use z-scores? We use z-scores when we have an unknown mean or standard deviation. Unknown mean or standard deviation, okay? And that's when we need to use a z-score to get something on the left-hand side so we can solve for an unknown variable. What did I just touch? Okay. So you can look at that. Remember those keystrokes on your calculator. And then let's look at some problems, okay? Scroll through these problems. Do you remember how to do this? The way that you get the z-score is you're going to do the inverse norm of that known area that's given in the problem, whatever it may be, area to the left. And then you have a mean of 0, a standard deviation of 1. That's going to get you your left-hand side. And then you have x minus the mean over your standard deviation, okay? That's how you solve for unknown means or standard deviations. Sometimes if you ever have two unknowns, the mean is unknown, the standard deviation is unknown, you're going to have to set up a system of equations. And you can just type that into LinSolve. Remember how to get to LinSolve. It's menu 3, 2, okay? Scroll through these problems. We didn't do this in class, but this could be a good review, trying to figure out which, if you would use inverse norm or normal CDF. Make sure you finish these classwork problems from that day because those were super challenging, and if you can do those, you're good. I posted a key to them. Overarching ideas, right? When to use inverse norm, when to use normal CDF, making sure that you always draw a bell curve every single time so you know exactly what areas you're trying to find, what areas you already know. When does that LinSolve case arise? When we have an unknown mean and we have an unknown standard deviation, right? These are the stop popping up. These are the sorry, I'm distracted by the fact that this thing won't let me scroll. Okay. These are the relationships that we're trying to build in our own head, okay? So let's go ahead back and take a look. We got more problems. Scroll through. Do you know how to do these? Yes, no, maybe so. Cool. I feel like that's pretty much the heavy hitters for what you're going to be asked about. Make sure that you review the givens playlist so you figure out how to find the probabilities in sneaky given cases, okay? I posted that playlist under the Unit 3 review key. Let's go through our Unit 3 review now. Oh my goodness, it just X'd out what I was doing. Okay, thanks. Now go through your review key, okay? And look through all these problems. Did you know how to do these? Do you have any questions, right? Make sure that you know how to figure out the tricky given ones, the videos that I posted. I think this has kind of been an overarching review of everything that we went over. I did the heavy hitters for you. Now it's your job to zero in on stuff you don't know. Good luck and have a good study session.